Application of dot product perpendicular vectors C3. Rectangle ABCD has vertices A, which is minus 1, 2, 3, B as 2, 6, minus 9, and D as 3, Q, 8. Determine the coordinates of vertex C. Now in this kind of questions, we should first sketch a rectangle. And let me alert you here. When you are sketching a rectangle, just sketch a normal rectangle, kind of straight as we normally do, right? Don't try to get to a point with coordinate systems, and that will be a lot of wastage of time and you don't really need it, right? So just sketch and write your points in an order. That means A, B, C, D you can write anywhere. So you can start from here, for example, and A in this case is minus 1, 2, 3. So I'm telling you the method of doing it. It is 2, 6 and minus 9. And then C we don't know. So let's write X, Y and Z. And this is point D, which is 3, Q and 8. Now since it is a rectangle, we know these sides are at right angles and they are parallel too, correct? So that is what we know about a rectangle. That really represents the situation. Now what we need to find is the value of Q and these 3 points. Now how to find this? You can note that AB is actually perpendicular to AD. That means the dot product is going to be 0. And so let's equate AB dot AD to 0, right? To 0. And then evaluate point Q. So this is the first step. So AB, what is AB? AB is B minus A, the coordinate points, right? So I'll write AB here as 2 minus 1, which is 3, 2 minus of minus 1, which is 3, 6 minus 2, which is 4, minus 9 minus 3 is minus 12. That is AB. Dot AD. A to D. A to D will do 3 minus minus of 1, which is 4, Q minus 2, and 8 minus 3, which is 5, equals to 0. So we can write like this, right? So we know the dot product should be 0. Now let's get the dot product. So 3 times 4 is 12. 4 times this is 4 times Q minus 2. Let's write Q minus 2. And minus 12 times 5 will give me minus 60, equals to 0, right? So you get this. Now in this equation, there is only one unknown, which is Q, and you can always find that, right? So we can solve this. We get 4 Q minus 2 equals to minus 60 will go that side, become plus. Well, you can do here also. Minus 60 plus 12 is what? 48. So when we bring it to that, minus 48, it becomes plus 48, right? So we get plus 48 here, right? If you add 12 to this, it becomes 60. That's the correct. Now Q minus 2, let's divide by 4, and we get 4 times 2, 12, right? So dividing by 4, and we get 12. And therefore, Q is equals to 12 plus 2, which is 14. So we get the value of Q as 14, right? Now we know point Q is 14. So we have this point as 3, 14, and 8. Now to find C, what should we do? To find C, we'll adopt that they are parallel, right? They are parallel. So we can use that, or you can do AD plus AB will also give you C. So that is another way of finding C, right? So either method is good enough. The method you can adopt is using parallel lines. Or the other method could be sum of vectors. So at this stage, both will work, right? Now to find C, what we notice is that BC is equals to AD. So let's do BC is equals to AD. So what is BC? BC is x minus 2, y minus 6, z minus 9, that is z plus 9, right? Minus of minus, this is BC. And what is AD? A to D is 3 minus 1, which is 4. Q is 14 now. 14 minus 2, which is 12. And 8 minus 3, which is 5. So that gives us three different equations. X is equal to, now x minus 2 is 4, right? So x minus 2 equals to 4. That means x is equals to 6. Y minus 6 is equals to 12. That means y equals to 18. 12 plus 6. And z plus 9 equals to 5. So z equals to 5 minus 9, which is minus 4. And so we get the point C. And our answer is Q is equals to 14 and C is equal to 16, 18 minus 4, right? So that is how we can solve this question. Thank you.